Welcome to a short video on AI-powered database automation with Severalnines ClusterControl. In this short video, we will cover topics such as what is cluster control, how cluster control helps either DBOps, ITOps, or DBAs with their day-to-day tasks, how to deploy a new database cluster or import an existing database cluster using cluster control, how cluster control helps maintain high database uptime with auto failover, how you can achieve your disaster recovery strategy with automated backups and setting up hot standby instances or clusters in a disaster recovery site, how cluster control simplifies deployment of database proxies and load balancers that help scale your existing databases, how several built-in database advisors in cluster control help detect potential problems in various areas of your database, how database metrics collection, analysis, and alerting in cluster control help minimize downtime by taking proactive actions, and finally, how cluster control's built-in capability to perform query analysis and query debugging helps isolate and fix problematic queries. Cluster control is an AI-powered database automation tool that simplifies the tasks that DBOps, ITOps, and DBAs have to perform on a day-to-day basis. Cluster control takes care of maintaining database uptime, automating the tasks of taking backups, and monitors and alerts on database performance, just to name a few. Cluster control automates and simplifies many more DBA tasks. Cluster control helps DBAs and DBOps with simplifying the deployment of new database clusters, example Galera cluster, Postgres, MySQL, MariaDB active standby clusters, MongoDB sharded or replica set clusters, Redis Sentinel clusters, and Microsoft MS SQL clusters. Further, cluster control helps provide the highest possible database uptime by automating database failover to standby instance, automating the task of taking scheduled backups, both full and incremental, simplifying the setup of standby instances in a remote DR site, monitoring and alerting on database performance, analyzing database queries and isolating problematic ones, finding potential security holes in your database configuration, performing schema analysis, and many more best practice checks for all the database technologies it supports. In this segment, we will show how cluster control simplifies firstly, deployment of a new multi-master 3-node Galera cluster, and secondly, importing a multi-master 3-node Galera cluster into the management purview of cluster control. Let's get started with deploying the Galera cluster. Cluster control supports many different database technologies and clustering types. For example, cluster control supports MySQL and MariaDB active standby clusters, MySQL and MariaDB Galera clusters, MySQL NDB clusters, Postgres timescale clusters, Postgres clusters, MongoDB replica set and MongoDB sharded clusters, Redis Sentinel clusters, and finally Microsoft MS SQL clusters. Let's get started with deploying a Galera cluster. Enter some basic information such as the root user and the path to the SSH key. Perform an SSH for cluster control to log in to the database nodes. Enter a cluster name. Optionally add some tags and leave the rest of the options as defaults. Here select the version of the Galera cluster, ProconXtraDB 8.0 and 5.7, MariaDB 10.5 through 10.2. For this, we will be selecting ProconXtraDB version 8. Enter a root password for the MySQL database. Leave SSL encryption enabled. Add the 3 Galera cluster database nodes one by one. Finally, deploy the 3-node Galera cluster using cluster control. The 3-node Galera cluster has been successfully deployed by ClusterControl. Hovering over some of the attributes indicates that auto recovery for the cluster has been turned on by default. It's a 3-node Galera cluster with all the 3 nodes are available and functioning, and all 3 nodes are master nodes accepting writes. Clicking into the overview shows some basic information at a very high level. The information provides cluster load by default, and then one can also select other metrics such as Galera replication, InnoDB disk IO, query performance, node status, CPU usage, disk statistics, network statistics. The Nodes tab provides host-level charts. A quick summary of the host. And for the remaining nodes in the cluster, the top processes running on the host, database performance at a glance, database status variables and internal counters, database variables, current database deployment topology showing multi-master Galera cluster. A shortcut for performing operations on a database node, such as, for example, bootstrapping a Galera cluster from this particular node, restarting a node, etc. In this segment, we will show how to import an already deployed Galera cluster into the management purview of ClusterControl. Click on Get Started and choose the Import Existing Server or Database option. Here, navigate to the MySQL Galera option. Once there, enter the credentials for the root user and the SSH key path if they're different from the defaults that are shown. Enter a name for the cluster. Optionally, provide any tags. Set the MySQL server port and the admin user if they differ from the ones that are shown. Also, provide the appropriate password for the admin user. For the remaining fields, choose the default ones. Add any one of the Galera nodes in the Add Node field. Finally, click Import. A multi-node Galera cluster has been successfully imported into ClusterControl. Cluster auto recovery and node auto recovery are not enabled by default for clusters that are imported. However, you can quickly enable them. ClusterControl immediately starts collecting data for imported clusters and makes them available for viewing. You can visualize the deployment topology of the Galera cluster from the Topology tab. In this segment, we will show Cluster Control's auto recovery capabilities. As part of auto recovery, Cluster Control is able to detect a failed primary database node and automatically promote a standby database to assume the role of the primary database. Cluster Control is capable of performing auto recovery for MySQL, Postgres, MongoDB, both sharded and replica set configurations, Redis, and Microsoft SQL Server. Further, post-auto recovery, Cluster Control is capable of auto-provisioning a failed primary database as a new standby database. In order to demonstrate Cluster Control's auto-recovery capabilities, we will be using a Postgres hot standby setup. However, Cluster Control's auto-recovery is equally supported for MySQL, MongoDB, Redis, and Microsoft SQL Server. Before we fail the primary Postgres database instance, let's go ahead and configure Cluster Control to automatically rebuild the failed primary instance as a standby instance. We will first check to make sure that Cluster Auto Recovery and Node Auto Recovery are on for the Postgres cluster. The topology view shows that PG-1 is the primary database instance in this Postgres cluster. We will now reboot the primary database instance PG-1. Cluster Control has detected that the primary database instance PG-1 has failed and has subsequently kicked off an internal job to promote the standby instance. If the failed primary becomes available, it will be automatically provisioned as a hot standby. Within a few seconds, the hot standby has been promoted successfully to assume the role of the new primary database instance. As the final successful act, Cluster Control has re-provisioned the failed primary instance as a new hot standby instance. In this segment, we will show Cluster Control's DR capabilities, which includes database backups and provisioning of DR clusters or DR hot standby database instances. For this portion of the video, we will work with a MySQL primary hot standby setup. First, we will configure global backup settings for this cluster. Global backup settings for a cluster include items such as backup directory and format, netcat port, enabling hash check on the created backup files, and finally, backup retention period. Let's go ahead and create an ad hoc full backup. We will take a full binary backup using the extra backup tool. We will take the backup on the MySQL master node, and we will store the backup on the master node itself. We will go with the defaults for compression, encryption, locks, and retention. A backup creation job has been kicked off by Cluster Control. Backup creation has completed successfully. Backups can be restored, uploaded to the cloud, or deleted. In this segment, we will show how to schedule backups using Cluster Control. For this portion of the video, we'll be using a MySQL Galera cluster. Instead of ad hoc backups, select Schedule Backups. We will now schedule a full binary backup at 01:30 hours UTC. Select defaults for rest of the fields. Select backup encryption, backup compression, number of parallel threads, verify backup, and retention if different from global backup settings for this particular cluster. The newly scheduled full binary backup shows up under Scheduled Backups. Changes to an existing backup schedule can be made from the console. Scheduled backups can be disabled. We will now schedule incremental binary backups for 5 minutes past every hour. Similarly, we can continue to schedule incremental binary backups to occur every 10, 15, 20, etc. minutes past every hour, or some other schedule such as every 15 minutes past every hour. Continuing with the theme of database backups, we will now show how to attain peace of mind regarding the integrity of your backups with the automatic backup verification feature in ClusterControl. Continuing with the theme of database backups, we will now show the database backup restore options that are supported by ClusterControl. To demonstrate database restore, we will be using the MySQL Galera cluster that we have already set up and for which we have already taken an ad hoc full binary backup. For the Galera restore, we will first demonstrate the restore on the same node option. For this option, the backup will be restored on one of the nodes in the Galera cluster, and that node can then be used to bootstrap the entire cluster. Secondly, we will demonstrate the restore and verify on standalone host option. With this option, a new standalone Galera node will be set up with the restored backup. Third and finally, we will demonstrate the Create Cluster from Backup restore option. With this option, a new Galera cluster will be set up from the backup. We also show point-in-time restore options. Specify the operating system root user or sudo user, credentials, and keys similar to the scenario for deploying a new cluster. Name the cluster and provide optional tags for it. Choose the Galera distribution, namely Percona XtraDB or MariaDB Galera, and the respective versions. Add a password for the root database user. And finally, add the hosts that will make up the cluster and deploy it. Continuing with the disaster recovery theme, in this segment of the demonstration, we will show how one can quickly deploy a hot standby database in a remote data center or different cloud region. For the purposes of this demonstration, we will use a Postgres primary standby setup. Choose Add a Replication Slave from the menu for the Postgres cluster and subsequently choose Add New Replication Slave option. The primary Postgres instance will be auto-selected for you. Enter the host you have already set up in the remote DR. Choose between synchronous and asynchronous replication. It is recommended you select asynchronous for an instance running in a remote DR. If you have load balancers set up for the cluster and you wish those load balancers auto-adjust to the new hot standby instance you're adding, indicate that choice. Check on the progress of the standby deployment. The standby is almost ready. The standby is now ready. We can add PG Bouncer to the new remote standby instance we just created. Select the Postgres instance associated with this PG Bouncer. PG Bouncer has been successfully added to the remote Postgres instance. Let's check the load balancer to make sure it has auto-adjusted its configuration to the new remote Postgres instance. The load balancer read-write group accurately excludes the new remote standby read-only instance. Read-only group accurately includes the new remote standby instance. Further, it has tagged it has a backup instance, that is, it is not the preferred choice for read workloads. In this segment, we will show how to deploy database proxies, connection pullers, and load balancers to maximize database performance and scalability on limited computing resources. We will demonstrate proxy SQL deployment to a primary standby MySQL setup. Start by choosing Add Load Balancer from the top menu for the cluster. Add the proxy SQL host. It is preferred that proxy SQL is not co-located on the same host as the database instance. Examine proxy SQL read-write splitting auto configuration from the ClusterControl UI. Take advantage of weighted routing in proxy SQL. In continuing with the proxies and load balancers theme, we will now show how to deploy HA proxy for a Postgres primary standby setup. At the HA proxy host, it is preferred that HA proxy is not co-located on the same host as the database instance. We will tell HA proxy that PG bouncer is set up in front of the Postgres instances. We will examine HA proxy configuration to make sure it is set up for read-write and read-only workloads. ClusterControl comes with purpose-built best practice database and host advisors that help keep the database secure and performing well. Security advisors check the database against known best practice recommendations. Schema advisors help keep the database performing well by continuously checking for known schema best practices. Host advisors make sure the host operating system is configured for demanding database workloads. There are many more purpose-built best practice advisors for replication, InnoDB storage engine, to name a few. In this segment, we will show the collection of metrics-based dashboards for MySQL, Postgres, MongoDB, etc. that are available in ClusterControl, along with its metrics-based alerting capability. The rich set of visuals, graphs, and charts make it easy for you to visualize the performance of all your database clusters in one tool, making it easy for you to A. Observe historical performance characteristics of all your database clusters, B. Troubleshoot and root cause performance problems, C. Understand trends in database use patterns. D. Anticipate future needs and use it for capacity planning. E. Receive proactive alerts on any of your databases before problems result in a database outage. In order for the user to be able to focus on specific problem areas, the metrics dashboards are categorized into system-level dashboards, cluster overview dashboards, and database technology-specific dashboards. For MySQL, you can find general server-level dashboards along with ones pertaining specifically to InnoDB storage engine and other cache and database user metrics. System overview dashboards provide insight into how various subsystems such as, for example, the disk subsystem is performing. You can quickly view disk IOPS, both read and write, disk throughput, and available disk space that are important for the smooth operation of the database. Cluster overview dashboards provide a quick view into what's taking place at the cluster level. Here, a cluster could be a multi-master Galera cluster, or active primary with hot standby based MySQL or Postgres clusters, or MongoDB replica set and sharded clusters. General MySQL server-level dashboards provide insight into how the MySQL server is performing. You can find a quick summary of query performance in queries per second, InnoDB buffer pool hit ratio, database connections used, etc. Further, time-based charts are available for table locking, scan operations, memory utilization, to name a few. The set of charts under the cache category provide insight into how the various table level, storage engine level, and general server level caches are being used. The storage engine specific dashboards provide insight into how the engine has performed over time. For debugging at the node level, one can navigate to the set of dashboards that are available under the Nodes tab and filter on the respective node of interest. You can take advantage of the database performance charts that are available on a per node basis for further exploration and debugging. Through cluster control, you can quickly see the result of the host level top command. By navigating to the Performance tab and selecting Overview, you can visualize the database performance charts for your cluster. We will show charts for MongoDB now. We will explore topology and database performance dashboards for a sharded MongoDB deployment. Here too, performance dashboards are categorized into system and cluster-specific ones and MongoDB-specific ones. The objective of these extensive and focused charts is to provide you with the necessary information required to debug potential performance problems and a tool to plan for anticipated future needs of your application. A quick view into MongoDB's ops counters. Continuing with the theme of monitoring and alerting, in this segment we will show how to configure performance thresholds that result in alarms, how to visualize alarms, and finally, how to integrate with third-party alert management systems. Alarms for a cluster can be examined by drilling down into the cluster. Alarms for all the clusters, that is alarms at a global level, can be viewed by navigating to the Activities section. You can set appropriate thresholds for various performance-based alerts based on your preference and tolerance level. You can subsequently configure email notifications for alarms. Finally, you can configure alarm forwarding to your favorite third-party alert management system. In this segment of the video, we will show the capabilities that Cluster Control brings to bear in the area of query analysis and query debugging. One can quickly visualize the top-end queries and further set the appropriate threshold for long-running queries for both tracking and alerting purposes. One can visualize current database connections to determine if the database is configured for an adequate number of client connections. Further, if a long-running query is holding table locks, the connection used by that query can be killed from the UI. For queries that normally execute in a predictable fashion, but for some reason take much longer on the odd occasion, you can find those outliers in Cluster Control. Cluster Control helps with transaction deadlock detection by first alerting on long-running queries that are potentially waiting for table locks to be released, and secondly, displaying such queries. Cluster Control allows you to obtain the details of the deadlock from the InnoDB storage engine. To recap, we have shown how Cluster Control helps DBOps, ITOps, and DBAs with their day-to-day tasks in making sure databases used by mission-critical applications have the highest possible uptime with auto-recovery and disaster recovery features, along with a rich set of monitoring and proactive alerting capabilities. We hope you found this video useful. Thank you for viewing this video, and please follow us on LinkedIn and Twitter for product updates and company announcements.